So from the T2 value, we can now calculate what T1 is. We know the equation T1 by T2 is 51, and T1 is given data, it is as 9 kilonewton, which is here 9000 Newton. From that we can identify what is tension on the slack side is. Tension on the slack side is T2, which is 176.47 Newton. And now the second is power to raise the casting. We know the formula for power, T1 minus T2 into velocity. Velocity, we need to ensure that the unit is meter per second. So because in the previous problem we have been seen that the radius of all the pulleys in mm. So for not for all the cases we need to consider mm. In case if it is velocity determining factor, the unit should be meter per second. Therefore the given diameter is 300 mm, converting it to meter is 0.3 meter, and now substitute pi d n by 60. N is 20 rpm, which has already given. Substituting with that, we can identify what is the velocity. Speed is, that is 0.3142 meter per second. And now calculate what the power is in terms of watt or kilowatt. It is 2772 watt or 2.77 kilowatt. And next we are going to see the problem on a centrifugal tension. That's very simple. Okay, so a leather belt is required to transmit 7.5 kilowatt from a pulley of 1.2 meter in dia, which is running at 250 rpm. So the embraced angle is 165 degree, and the coefficient of friction of the belt and the pulley is 0.3, and the safe working stress for the belt is 1.5 megapascal, that is 10 power 6 Newton per meter square. Again they have given density of leather. So there is a density, we know density is equal to mass by volume. We are somewhere else we are going to identify this. So density is 1 milligram per meter cube, right? 1 milligram. Okay, and thickness of, not milligram, it is 1 molar gram per meter cube, and we need to identify what it is. Okay, and thickness of the belt is 10 mm. Determine the width of the belt taking centrifugal tension into account here. So the density is given as 1 into megagram. Mega, they have been given that capital M as m mega, therefore 1 into 10 power 6 gram per meter cube, which was 1000 kilogram per meter cube. It is actually a wrong data. There is nothing like megagram. Okay, and all the given data has to be prescribed as like here. And now we need to identify, they are asked to determine the width of the belt taking centrifugal tension. For determining the width of the belt, we require certain parameters or certain criteria. That is, we need to identify what is the tension on both the tension. For both the tension we need to calculate power. For the power we need velocity. For velocity we know the formula pi d n by 60. D in terms of meter, substituting it, calculating what is the velocity is, and now velocity is 15.7 meter per second. Okay, and the power was given as 7.5 kilowatt. Therefore now T1, the difference in tension, that is the tight side and slack side, we have been now got a value. What is the difference in tension, not the actual tension value of a tight side or neither a slack side, but the difference in tension is 477.4 Newton. And now we know the data, or we know the formula, 2.3 log of T1 by T2 is equal to e power mu theta, which is equal to mu is 0.3, theta is 2.88 radian. Why it is 2.88 radian? The value, the theta is 165 degree, I think here. For 165 degree, 165 into pi by 180. Here 165 into pi by 180. Substituting this, we can get 2.88 radian. So we are substituting here, and the value is 0.864. And dividing this 0.864 with respect to 2.3 will gives you 0.3756. And now we know what is T1 by T2 is. T1 by T2 is equal to 2.375. Because we need to remove the log, therefore I am going to take anti-log for the same. Taking anti-log for the 0.3756, I can get T1 by T2 equal to 2.375. we already know the difference in tension is 477. So we have two equations, equation 1 and equation 2. From this, in T1 with respect to T2, we can write T1 is equal to 2.375 T2. So substituting T1 as 2.375 T2 minus T2, which is taking common out of T2, we can get 1.1375 and sorry 1.375. From that we can identify what is T1 and what is T2 is. Okay, and now comes the major part. They have given density. We know density is equal to mass by volume. Somewhere else it is going to play a vital role. For mass it is nothing issue, but for volume we need to calculate what is the area and what is the length. Area is meter square, length is meter, therefore it is meter cube, hence it is volume. For density they have given some value. So now we are going to determine the mass. Density is equal to mass by volume, and mass is equal to density into volume. Volume is area into length, and this is density, which is equal to area breadth into thickness, length L. Density it is given as 1000 kilogram per meter cube. Substituting all the known values, we don't know what is the breadth is, but the thickness they have given 0.01. In terms of meter we need to write everything, and with that, in terms of meter, why it is in terms of meter? Because we have taken the density in kilogram per meter cube. Therefore taking in terms of meter cube of 10 value, which is should be all the value should be in meter, and mass is 10 times the breadth in terms of kg. And now for centrifugal tension, this is your formula. You just have the formula for centrifugal tension as m into v square. We know the mass 10b. We know the v square velocity 15.71. We have already calculated while deriving this equation t1 t2. For substituting this velocity v value, we have identified v as 15.7 meter per second. Substituting that, we can get in terms of Newton with respect to b. Okay, since we have not identified what B is, and now the maximum tension in the belt, this is the second formula you need to take up. The maximum tension in the belt formula is tension is equal to sigma into B into T. It's very simple. Maximum tension, we know stress is equal to load by area. Tension, the unit is Newton. For the load also the unit is Newton. For area, meter square. Here area B into T. B is meter and T is also in meter. We can get meter square. Therefore sigma is stress. So simply you just have stress is equal to load by area. Here load is equal to stress into area. So stress is 1.5 megapascal and area is breadth into thickness. We don't know what B is, but thickness 0.01, and which is equal to, that is the maximum tension is nothing but 15,000 times of B. And now the tension is equal to, there are two different tension. One is per unit tension, that is T1 and T2 are the two different tension at the slack side plus tension on the centrifugal area gives you the maximum tension T, which is equal to, in terms of B we can identify what is B is. From this equation we can reduce it to B as a 824.6 by 12532, which is equal to 65.8 mm. In terms of mm we have identified here, right? Don't confuse with the meter and mm. Okay, we have identified in meter, and finally we have been converting that meter into mm, 65.8. The solution will be in meter, because while calculating tensions, all the velocities, all the density, wherever we met with the data, it is in meter. Therefore your answer will be in meter only. After calculating the answer, just convert it to mm. Since all the given data have been given in mm, I am just converting the data in mm. So far we have crossed the two problems. These two are very most important problems, and finally we are going for V-belt drive and the chain drive. We'll take up those sessions in another video. And thank you so much students for having the patience while learning this content. Thank you.